Okay, this is the lesson 5.2, solve systems of linear equations by substitution notes. So we're going to go ahead and get into it here a little bit. I think this is kind of a one-day note where we won't break it into part one and part two, but it is fairly complex. We might spend another day or another assignment practicing it. So follow along. I would encourage you to not only just watch the video, but maybe do some of the practice with me, just in a notebook. It's not going to hurt to get some of that practice where you're actually going through the process of doing what I'm doing versus just watching it. So something to consider as we go through it. So we've solved systems by graphing. There's no graphing in this lesson. That's kind of a nice thing. I might have you do some review ones on the assignment. I can look here. I think there's two of them that I have you do as review. So I'll do kind of the same thing with the previous lesson. We'll go side by side, but if you take a look, this is these are the last two on the homework. So there's 10 total questions, and it's a review of 5.1. So when you get there, that's just kind of reviewing some 5.1. So there's really only 8 problems on the actual assignment. You can kind of see it spread out here for the assignment. So I'm just kind of going back and forth. I'll do like I did for the previous lesson. So no actual graphing in lesson 5.2, but we're going to recall some other skills to help us solve using substitution. Okay, so we'll go through the exploration here relatively quickly. Again, this is kind of reviewing some skills that we should be familiar with, that we've done this school year, that's going to tie into today's lesson. Okay, so I'm going to get my pen going here. Let's see, get my colors ready to roll. All right, I think we're okay. So for this first exploration that we're going to do, you notice for this one that it's asking us to solve for x, and this one's asking to solve for y. What's the interpretation there? It's really get, ooh, that's a little too big there. Get x by itself. Be a little skinny even. All right. So same thing on here, get y by itself. That's one of the big skills we're going to have to do for this lesson. And it's going to vary kind of on the equation to see like how much work it is. So as I look at this first one, and I don't want to spend forever reviewing this, I want to spend the majority of the lesson kind of actually doing the new stuff, but it's important that we know how to do this. How do I get this x by itself? Right now there's a plus 4y with it. So to get it by itself, I need to get rid of this 4y. How would you get rid of a positive 4y? You would subtract a 4y from both sides of the equation. Okay, that leaves us with the x all by itself over here, which was our goal. And then on the right side, we just got to be careful. Most of us have no issue with this, but remember, I can't combine these and make this 26y. They're not like terms. So however you write it, you could write this as 30 minus 4y, I think would be okay. Let me see what's going on with this pen here. Some of us might want to write this depending on kind of what we're doing. You could also write it as, that's a little better, I think. X equals negative 4y plus 30. So I hate to give us multiple different ways, but I know some of us see it like that. Some of us would rather, because a lot of times for slope-intercept form, we're putting this in front of the 30 and saying negative 4y plus 30. Totally fine. Or I can just go 30 minus 4y and just write it as it is. Either one is okay. Okay? Same process here. For number 2, get the x by itself. Solve for x. When I see solve for x, get the x by itself. There's different options here. I'm actually going to do this one 2 different ways. Okay, so some of us see this as, all right, there's a negative 2y here. How do I get rid of a negative 2y? I need to add 2y to both sides of the equation. Okay, because over here, negative 2y plus 2y is 0. We still have a negative x over here equal to 0 plus 2y. 0 plus 2y is 2y. Now the x isn't truly by itself, so I need to get rid of this little negative 1 that's in front of it. So I think most of us would divide by negative 1 to get the negatives to cancel and leave us, that's a negative 1 there, and leave us with 2y divided by negative 1, which is equal to negative 2y. And I would say, there we go. X equals, the x is by itself, that was our goal. is equal to negative 2y. The alternative here, I'm just going to rewrite the original problem. Negative 2y minus x equals 0. Instead of moving this and then getting rid of this minus like we did originally here, that was how we did the problem the first time, some of us see this as, this is just minus x. What if I just brought this x to the other side of the equation? It's actually going to end up being one less kind of move we have to make. So these x's, the negative x plus x is 0. They cancel out. So we're still left with a negative 2y here. That's y. And then 0 plus x, we can do that. X plus 0 or 0 plus x is just x. So we end up with the x by itself on this side of the equation, which was our goal. It didn't say it had to be on the left side. But now it's backwards, but it's one less step, and it's x is equal to negative 2y, x is equal to negative 2y. So it really doesn't matter which way we go, but that's kind of the whole point of this section here, is solving for a variable. It doesn't have to be x, it could be y. So if we take a look, let's change colors here and go solve for y. It's the same process, nothing changes. You just got to pay attention to which one did you solve for. I solved for, now it's asking us to get the y by itself. So this is another one that I think, like the first one, kind of a single step. I can move this 2x through subtraction, minus 2x from both sides of the equation. 2x minus 2x is 0, leaves us a y. And then however you want to write it, I'm not going to write it both ways. I'm going to just pick one way and just do it. So negative 10 minus 2x is what we're going with here. Just know that you could stick that negative 2x in the front, minus 10, and that would be okay. It didn't say we had to write it a certain way. Over here, there's options. I don't think there's any one long or short way to do it. Maybe I'll change it up a little bit and kind of do like we did above here and say, you know what, I see a minus y. I'm going to add y to both sides. So it's a plus y here, plus y here. That leaves us on the left side, still with the 3x. What's going on with my pen here today? Equal to 5, that's a plus y, I can't even read my own writing. 5 plus y. So we're not done. All I did was move the y to the other side. The reason I thought about maybe doing that first was just to get the y positive. So now it's a plus y. So I still do have a second step regardless on this one. So to get rid of this, get this y truly by itself, I need to subtract a 5 from both sides, which is going to leave now on the right side the y all by itself. 5 minus 5 is 0, so y is by itself now. And however you want to write it, I'm going to write it as 3x minus 5. So y equals 3x minus 5. So that's really one of the big skills we're going to have to do here for today's lesson. Lesson 5.2, when we start solving by substitution. So that's kind of a review concept for us, going back and just getting a variable by itself. Okay. Kind of extending it here a little bit. The only difference between what I'm asking you to do here in this section, this exploration number 2, is you get to decide. Pick one that would be easier and solve for that variable. So there's some open-endedness to a question like this. I'm not saying you solve for x or solve for y. You have choice. Choose a variable. And a lot of times there is going to be one that's easier than another. But ultimately, there's not necessarily a wrong answer here. Okay, so if I wanted to get this x by itself, I could do that. This is one, and I think we'll kind of start to see, usually when it's just the variable with no number in front of it other than 1 or negative 1, like this one has a negative 1 in front of it. Both of these have 1 and negative 1, and a 1. Usually it's the one that's by itself that's going to be the easiest one to get rid of. So for us, I'm going to maybe go back here and see if I can take that purple off there just so we can kind of see it. I would personally choose to get this y by itself. It's going to be less work. We're not going to have to divide by 5 at some point. Okay, so when in doubt, pick the variable that doesn't have anything in front of it. It could be plus, could be minus, that's okay. But usually if there's a number there, it's going to be one extra step. So for me, I'm going to choose y here. And this, just as a heads up, so you can kind of see where we're going with this, this will be the first part of your homework will be just like this. Okay, where you're going to pick a variable, look at the directions are the same, choose which variable would be easiest to solve for, then solve for that variable. So I'm not necessarily, as far as how we're doing this, I'm just going to say maybe off to the side here, I'm going to get the y by itself. That's all you kind of have to say. Let me know what you're doing. All right, I'm going to get the y by itself for this one. So to do that, again, I have choices. I could subtract the 5x and divide by -1. I could, I'm going to do it this way, where I'm going to, like kind of like we did in the last problem, add y to both sides, so plus y to get rid of those. 5x equals 5 plus y. Still not done, all right? I didn't finish it. They're not all going to be one steps, and this is a good example of, I mean, a lot of times they're going to be more than a single step. But get this y, that's what we started with, by itself. So I'm going to subtract 5 from both sides, and just be careful again. We're not going to combine this. This isn't 0x or anything like that. That's 5x minus 5 equals y, and we are done. Okay, get a variable by itself. Here, it almost doesn't matter. I would say there's the x, because it's a positive one, is going to be always a little bit easier. So if there's ever a positive 1 in front of your variable, like there is here and here, that would probably be the easiest, usually one step one. Although again, y wouldn't be terrible either. Okay, so I'm gonna choose x for this one, just to kind of change it up, and I think it will be a little bit easier. And I think a lot of us can see what's going to happen here. Why would x maybe be a little bit easier? Because if I choose to solve for x, and I add y to both sides, okay, -y plus y is 0. These cancel out, so you're left with just that x already by itself on that side. And then as long as you're remembering to not combine these on the right side and just leave it as -3 plus y, we're done. So that's an example of a single step. 3 is going to be very similar. Okay, we'll go a little bit quicker on these ones, just because I think by now you should hopefully have a pretty good feel for what's going on. I'm going to choose to get this y because it's a positive 1 in front of it. So I'm going to just leave a little note to myself, hey, I'm getting the y by itself. And when I go to do that, what do we have to get rid of? This whole thing. Keep it together. Let's just move this whole x term to the other side. -2x from both sides. Go on. 2x minus 2x is 0, still leaving us a y over here. And then -10 minus 2x. We are, as long as you can read it, that's an x. We are done. It's not a ton of work for one like 2 or 3. Usually with a negative there, like we're going to see here for 4, just like we saw with 1, usually about 2 steps. Okay, so between 1 and 2 steps. Last one. Let's do it this way. Let's get rid of the 2y. So I'm going to choose to get the x, isolate the x, get the x by itself. So minus a 2y from both sides. -x equals 10 minus 2y. And it's not by itself yet. Don't forget that negative was there, so I've got to, and here's one we haven't seen yet today. We've seen it multiple times in the past, but we haven't seen it yet today, at least, as far as finishing this one. We get the x by itself. Did we see it on the first one? I'm just second guessing myself. No, we saw it here, but there was only one number to divide by. So just make sure, in a case like this, when we have to divide by -1, we're dividing everything by -1. So 10 divided by -1 is -10, and then -2y divided by -1 actually makes it positive 2y. Okay, so we've seen that a lot. I just wanted to make sure to point that out here for that particular one. Okay, that's one of the first big skills, and that's why on the homework, 4 of the 10 problems is just you doing that. So you get choice. Tell me what variable you're going to work with, and get it by itself. I've left space. If you can print it, that's your lucky dog. You can print it. If not, you're just kind of copying the original down and working on it on a sheet of paper. Okay, so watch that section again if you're having trouble with it to help with the first part of the homework. All right, so that's actually a review. Here's kind of the new portion of what we're doing today. All right, the lesson 5.2 actually, we're still going back with systems. Remember, a system, a linear system, or a system of linear equations has more than one equation together. Those are all just single linear equations. We're working with systems, which is multiple, 2 or more equations on the same in the same equation, or the same problem. So we've solved by graphing. We looked at where do they intersect. Today we're solving using substitution. Okay, so a different method here. No graphing, which I think for a lot of us, we're like, yes, finally. Maybe we'll hold off on that because we'll see how this goes, and maybe you'll like this one better, maybe not. So it's just an alternative method for solving a system. So the first step, we've used this phrase in the past, is to isolate one variable, okay? Which basically we were just doing. In other words, we're get one variable by itself. So it's kind of like that last section where you get choice. You get to choose, do I want to get the x by itself? Do I want to get the y by itself? I think we'll maybe do an example of this kind of side by side. So step one, this is kind of, we'll do a problem that goes with it, is step one, we'll go back and forth between step one, and doing a step one with an actual system, kind of to put in the process, and then we'll do one just all as one. So maybe just keeping the same color. Step one, get one of the variables by itself. So in a linear system, remember when we saw these, we would graph these both. We're not graphing. I've got really kind of 4 variables to choose them. I know it's just x and y, so you could argue there's only 2. But total, there's a y here, there's an x here, there's an x here, and there's a y here. That first step is telling us get one of these 4 variables by itself. Either get this y by itself, get this x by itself, get this x by itself, or get this y by itself. You might be thinking, well, you're talking crazy, Mr. Crow. What are you talking about? This y is already by itself. And you're absolutely 100% right. So there's no way our step one of getting a variable by itself is already done for us. That's huge. We'll definitely take that, and we're going to see some like that. So there's going to be some on the homework. I'm kind of going back and forth. This is really the only other section on the homework, is if there's already a variable by itself, you don't have to go through that process of getting one by itself. Now on these ones, you're going to have to do a little work on that. There's not a single variable by itself, so we're going to have to do some rearranging. So we'll make sure we practice one of those on the notes here. Okay, so step one, for us it was done for this problem. Let's look at what step 2 would be. Here's where the actual substitution comes in, okay? Substitute the expression, from step 1 into the other equation. This one, it's a little bit more complicated than that sounds. So substitute the expression from step 1 into the other equation. And then there's kind of a follow-up. Solve for the remaining variable. So we just ramped it up here a little bit. There's a lot going on here with this one. This one takes some practice. So substitute the expression from step 1 into the other equation. Let's see what that looks like, that first part. Okay? So we're going to go back and forth just like we said. We've got one of the variables by itself, step 1. Step 2, I'm just using the colors here to remind us. Step 2 is take this entire thing, this negative 2x minus 9, and substitute, I'm going to actually circle it here. This negative 2x minus 9, wherever I see a y in the other equation, I'm going to substitute this whole thing in for it. So at this point, we need to do a little rewriting here. So follow along with me now. So 6x, did we say to do anything with the 6x? Nope, let's leave it there. So here's my work now starting to show up. 6x minus, did I do anything with this 5? Nope, I'm leaving this 5 here. But now we said we're going to substitute. I'm going to replace this y that was part of this other equation. I'm going to replace it with something that I know y is equal to. So instead of 5 times y, we've got to say 5, because this is 5 times y, right? 5 times this whole thing, negative 2x minus 9. Okay? That's the actual substitution part. Replace a variable, whatever variable you have isolated here, replace it with what we're saying it's equal to. Okay, this expression's going in here. Everything else gets copied down. The 6x, the minus, the 5, the equals now, we got to finish this one, equals negative 19. Okay, so we essentially rewrote this, but replaced the y with this expression. So that's the first part of that step that said substitute the expression from step 1 into the other equation. That alone is tough. Little things that I'm doing there that I didn't mention is use parentheses around this. They weren't there. We want to make sure we get parentheses around that whole thing. Okay, that'll be a common thing, or a common, I'm even going to put right here, use parentheses. Okay, because now, again, this is kind of a loaded step as far as there's a lot going on. Solve for the remaining variable. How many variables do I now have in what I just rewrote in purple here? I've got an x here, let's see, and I've got an x here. We've gotten rid of one of these variables. The y's have essentially kind of gone away. Now our job, which is, again, kind of loaded here, I'm going to kind of step 2, still step 2, but just to kind of distinguish a little bit, is now the second part is solve for this x. Get this x by itself. There's a lot going on here. Here we go. The first thing we're going to want to do is get rid of these darn parentheses that we kind of inserted here. So I need to multiply this 5 that's on the outside times everything that's on. And it's actually, I think this would be a spot where a lot of us would want to put a plus negative 5, because we all know that minus 5 is the same thing as plus negative 5. And I'm going to distribute this into this parentheses. This is another spot where I see subtraction. I'm going to switch it to plus negative 9. Okay, so that's kind of the first step, is distribute here. So let's see, I've got the 6x. We didn't do anything with. I'm going to just kind of keep this as a plus. Now here we go. I'm going negative 5 times negative 2x, which is positive 10x. Okay, we follow there. I did the negative 5 times negative 2 on the distribute. I've got one more distributive to do, so I'm going to just copy down this plus right here, and then go negative 5 times negative 9, which is positive 45. And then I didn't do anything else with this, equals negative 19. So that's going to be your first move, is get rid of those parentheses through this using the distributive property. I kind of picked a tough one here to start with, but I guess why not? We got to do it at some point. Okay. From here, things are starting to shape up a little bit. I'm going to actually, why not? Just let's keep it the same color because we're still in step 2. We can start to get stuff together. The parentheses are gone. I'm going to combine some like terms here. So 6x plus 10x is 16x. So you can kind of start to see why I've left so much space to do work. These take work. Okay, these are not ones that you can just jump to the final answer. Okay, so I've combined some like terms here, 6x plus 10x. It's getting there. We went from a whole bunch of terms down to 4, down to 3. Let's get this 45. So it's plus 45 right now, so I'm going to subtract. These are just kind of our old school equation solving skills at this point. 16x drops down. We didn't touch it yet. We brought it down from this step, so I'm going to go, I'm going to have to actually get my calculator out. You can't see me here, but I just don't want to make a mistake. Negative 19 minus 45. So we're equal to negative 64. So I just did negative 19 minus 45 is negative 64. And whew, finally, dividing both sides by 16, we get x equals negative 4. That's a lot of work, and unfortunately, that's kind of what we have there. And with substitute, we've done the bulk of the work. So believe it or not, you're kind of like, yeah, I'm not really on board with you, Mr. Crow, right now. That's the bulk of the work right there. Okay. We've got one of our answers. The goal of when we say, remember, solve an equation, solve the system, is figure out what x is, figure out what y is that works in both equations. So we just found half of our answer. Now, it's not that much work to get the other half. Let's go to our step 3 here. So it's actually a second substitution. Substitute the value from step 2 into either, or either, however you say it, of the original equations. And then solve for remaining variable. Okay, so again, that's kind of a mouthful there. Let's take a step back and just see what that is. It's almost like a repeat of step 2. Substitute the value, but instead of substituting the expression, that's what made that last one so tough, is because it was an expression. We were substituting this negative 2x minus 9. Now we're going to just substitute the value, which is just a negative 4. We're going to substitute that into either one of the original equations and solve for the remaining variable. So let's take a look at what that looks like. Again, definitely not nearly as much work. Step 3. Again, that's why there's all this space, and that's why there's only 8 new problems on the homework. So step 3 is go back to one of your original 2. I could use an eraser here. All right. Well, I've got this y equals negative 2x minus 9, which is, I think, where I want to go. So I have 2 choices. I can either take this negative 4, because it's x is equal to negative 4, and I could take this and I could plug it in for this x, or I could take it and plug it in for this x. The reason I'm going to pick this x is because once I plug this negative 4 in right there, I can go times negative 2 and subtract 9 and already have what my y is. Here I'm going to have to do a little rearranging. So here's our step 3 here. Just follow along here. I'm going to take, I'm taking this equation, and I'm going to maybe use an arrow here to kind of show what's going on there, and just kind of recopy it. Y equals, we didn't say anything about touching this negative 2, so I'm just copying it down. But then instead of going times x, we're going to replace x with something that it's equal to. We're going to replace it with, and I'm just using parentheses so we don't mix this up, and that's a 4, and think this is subtraction or something. Negative 2 times negative 4, that's a negative 4. And I'm going to keep copying, minus this 9. So here's what I mean by the work is not nearly as much. We're right there. Negative 2 times negative 4 is 8. Positive 8, negative times a negative is positive, minus 9. So y equals 8 minus 9 is negative 1. We've got our other value in 2 steps, really. This is just me circling my final answer versus da 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 da. So a lot of times that 3rd step, as long as this work is good, is going to be much simpler. okay? So we've got a value of x equals -4, y equals -1. One more step to go. And again, we're almost out of the woods here. I know it's a long example, I know it's a long notes, but this is kind of how you do substitution. It's hard to break up and to just do this part, just do that part. Our last step is check your solution by plugging in values of x and y into original equations. Okay, so our last step is a check. It's still important because I could have made a mistake anywhere, and I wouldn't know at this point unless I check my final answer. So step 4, which we'll do here in blue, is go back to your originals. I think this first one's going to be a real quick, easy one because I already know what we said. Y is -1. I kind of did it already a little bit. -1 should be equal to, let's see if I plug this in, where we kind of get the same thing over again. -2. So here's what I'm doing. I'm taking this -1. And I'm going to this first equation and replacing this y with -1. And I'm going to the x and replacing it with this -4, which, like I said, we kind of already just did. Not kind of, we did just do. So this one isn't really much of a check at all. We kind of used this one to find our answer. There's nothing to do here, and we already know what's going to happen. -2 times -4 is 8, minus 9 equals -1. We knew what was going to happen there. It's really this other one that a mistake would show up. Okay, so that's a simple check. The second check is right here. And there's a lot to actually do. 6, not a lot as far as like steps, but just a lot of operations. So 6 times, instead of x, 6 times -4. Okay, so I've replaced that x with a -4. I'm copying down the minus that's right here. 5. Instead of times y, we're going times what? What do we say y was equal to? -1. And then hopefully, if I do this, we should, if I did everything correctly, this number crunch should come out to -19. Let's check it out. What's 6 times -4? -24. What's, well, that's fine. -5 times -1 is +5. And -24 plus 5 is -19. So it does check out. That's my third or fourth deep sigh here during one example. So you can kind of see, maybe we're starting to rethink that graphing wasn't as bad as we thought it was. So there's a full-blown solve by substitution example. Some of the steps are easier than others. We didn't really have a step 1. Just think how much, I mean, there could be even potentially more work here if there was a step 1 where we had to get a variable by itself. Okay. Step 2 was kind of the big dog there, the substitution. Substitute and then simplify. These other 2 weren't terrible, but it's going to take practice. This isn't something you watch one example and then you're an expert at. Okay. I think what we'll do, I'll do one more kind of big ticket example where it's just full blown from the get-go. I'm going to pick one where we actually have a first step. So I'm going to jump ahead here a little bit to something like this, because this will be like your homework. So, well, they're going to be both like your homework. When you're going back and actually doing the homework side by side with this example that we just did right here, this process is going to be just like your numbers 5 and 6 now. Okay, we outlined what you should watch to do 1 through 4, get the variable by itself. That example that we just did, that's going to help you get through numbers 5 and 6, where you already have kind of that step 1 done for you. You're going to substitute, but again, look, you can see all that space there. That's the whole front side of the worksheet is basically you got half and half to do that. So I'm leaving you space to work. And then let's do one that's kind of like 7 and 8, just so we have, and you can break it up. You don't have to do this all, watch this video at once. It's probably going to end up being a 45-minute video. You can break it up and do it into parts. I'm giving you time on the assignment, so it's not due the next day, or even you get 3, 4, 5 days to do this. So break it up into parts. All right, let's do one. Step 1. Well, let's get to our problem here. So step 1, isolate a variable. Pick a variable and get it by itself. Remember, we have choice here. We have 4 choices for a variable. It doesn't always have to be x. We're kind of in this mindset, I think a lot of us have. We always got to get the y by itself. And it doesn't have to be. It could be this x, it could be this y, it could be this x, and it could be this y. Pick one and get it by itself. Right now, none of them are by itself. So I think out of ease, I'm going to pick one of the y's, because what did we talk about? We said having a positive 1 in front of the variable is going to make things just a little bit easier. So I'm going to come over here and just kind of recopy my original, negative x plus y. Because if I screw this first step up, I could do everything else right, but unfortunately, because I made a mistake originally, everything else that follows is probably going to be incorrect. So I'm going to pick this y. Let's get it by itself, like we were doing right on the front, some of the first stuff we did today. Isolate, pick a variable. I know both of these examples have been y. It does not always have to be y. That's just the way it worked out. Okay, so I've added an x to both sides of the equation. There's my step 1. I've gotten one of the variables by itself. Step 1, done. Not terrible. Could have been worse. Step 2, substitute. Here's that big dog substitution into the other equation. So here we go. Wherever I see, so I'm going to circle this, and this is usually how I do it. It wasn't just for show in that last example. Wherever I see, what are we going to substitute this 3 plus x in? This 3 plus x, wherever I see a y, I'm going to replace it with this 3 plus x. So I'm starting my step 2 right now. You kind of just go from copying down this equation, 3x, copy down the plus. Now the last one I think was tougher because we had a number. It was like 5y or something going on here where we had to distribute. If this is just y, I can replace this, and why not? Let's use parentheses. I put a big asterisk and said use parentheses. Let's put this as parentheses, 3 plus x. Okay, so I'm replacing this y. I'm saying get out of here, y. I'm going to replace you with this y, which we know is equal to 3 plus x. And then we're still equal. I'm just copying everything else down to negative 1. Okay? Where this one's slightly one less step, like I mentioned a second ago, is we don't have anything to distribute. There wasn't a number in front of this y. So this one does end up being kind of nice because it's addition. Just watch. If this was subtraction, we would have to distribute a minus sign in here. It's not. It's addition. So it's kind of just like, and we're not ignoring them, but we're just we can kind of get rid of those parentheses. It's like we just distributed the plus 3, plus x, there we go. So it's a step where I kind of just got rid of my parentheses. Second step here is what I did in the last example is I'm going to change colors. I know I'm not using the exact same color, so forgive me. But I'm going to combine my like terms. It's basically now get this x by itself. There's only one remaining variable. It's all down to x's now. So 3x plus 1x is 4x. I still have this plus 3 that I'm going to bring down to my next line, equal to negative 1. Let's see, let's get rid of this 3 by subtracting it from both sides. So I still have a 4x here. Negative 1 minus 3 is negative 4. And then I'm going to divide both sides by 4. I should probably scroll down a little bit. Just going to see what's going on here. And get x equals negative 1. I'm not promising, but I believe, don't quote me, but I believe I've set it up so at least these should work out to kind of integer, nice whole number, positive or negative whole numbers. So if you felt like you were dividing at some point and you got like 4 divided by 5, you probably made a mistake somewhere before that point, okay? So I'm not saying it always has to work out this way, but I think at least, and I'm not 100%, but I'm pretty close to 100%, that I believe I set all the homework up so these work up to kind of nice answers. We'll eventually get to where maybe they're not so nice, but I don't want any more frustration on top of what is already kind of a tough process. So there's kind of my step 2. I've substituted this in for y, and then I've solved for the remaining variable, which in this case was x. So we're up to our step 3 now. Go back to any one of your 2 original equations and replace, now that we kind of have half of our answer, take this x equals -1 and replace one of these x's, either this x or this x, with a -1. I'm actually going to use this one, and you'll see why here in a second, just because, actually you can see it right away. When I go to plug this in here, is this negative part of this x right now? Kind of, but I'm not substituting in for that, so here's kind of the thing you got to watch. Step 3. That's part of the equation. That negative sign is part of the equation. Now when I go to substitute for x, what is the value of x? X is equal to -1. So that's an easy thing to kind of mix up. That negative sign is just, that's there. That's part of the equation. The x is what's actually getting replaced. So that's why parentheses are important, and that's why I didn't skip them here. That x is -1, so when we end up with this minus -1 right next to each other, that's actually going to change the sign on our x. Anyways, let's finish this one. I'm going to copy the plus y equals 3. Plus y equals 3. Okay, so here's where it's important, because this negative right next to each other actually means 1 plus y equals 3. And then the finish, kind of a nice finish as well, because that y is kind of already by itself, or at least there's no number in front of it. 1 minus 1 is 0. So I end up with a y equals 3 minus 1, which is 2. It's another whole number, which if this one was, usually this one's going to be. So the last thing we have to do is check our solution. So there was our step 3, not a bunch of work, just a couple steps, a couple lines. Here's our check. Just stay with this first one. I know it's a little bit like, usually the one that you substituted in, it's going to be kind of the same type of thing. So if I plug in, remember, watch that first negative here. What is x? What are we saying? X is equal to -1 plus, instead of y, I'm going to replace y with 2. And then we should hopefully get 3. Now again, I know we kind of just did this one, negative 1 is really 1 plus 2. Yeah, I can tell right off the bat that for sure this one's checking out, and it should. We use that to find this, so that one's usually going to be okay. It's the other one we got to watch out for. Let's make sure it works here. So I'm going to go 3 times, instead of x, I'm going to replace x with -1, right? Because it's 3 times x, plus, instead of y, I'm going to replace the y with not this right here, 2. And I'm hoping that we get -1 when this is all said and done. So do it in steps. 3 times -1 is -3. Plus 2, oh, that's not showing up, equals, big equal sign, equals -1. Sure, -3 plus 2 is -1, which is equal to -1. Another time for a sigh. We did it. So, like I said, it's about a 45-minute lesson there. This example that we just did, you're going to use as far as kind of steps for you numbers 7 and 8 on your homework. Okay, so you should have now, I'm just staying on the homework here. Well, let's stay on the homework. I gave you a portion of the video notes to watch for 1 through 4. Go back and watch that section to help you with 1 through 4. We did, I know it was just one example, but they take darn near 10, 15 minutes to do. I gave you an example to watch that'll help you with 5 and 6. Okay, and then we did a second example that should help you with numbers 7 and 8. Okay, I do want you to do numbers 9 and 10. If you're stuck here and you say, I don't know what to do, then you got to go back and watch the lesson 5.1 notes. At least find a part where we're doing an example. And even here, there's two different examples from 5.1. I don't remember the exact numbers, but these are in slope intercept form. This is going to be a slightly easier or slightly less work than it's going to be for this one, just because the y is not by itself here. So go back and watch. If you're stuck here and you're like, I don't know what's going on, watch 5.1 notes to help you with both of these graphing ones, okay? It's very likely for that we'll do a much shorter notes, kind of a follow-up, a day 2, because obviously we only did 2 examples here together. I've left other work. There's different things that we can do in the notes. So I want you to, I'll give you till, I'll put the due date on here, but I'll give you 5 days to kind of work your way through. Now don't wait till the last day to start doing this, because like I said, this is a 45-minute video. So get started on it as soon as you can, submit your homework, make sure you're showing that work. I've been very clear with as far as like what you should be showing, what do I need to see. These are the ones that if you're looking for work, go back and look at what I showed. I'm not doing that for fun. That's what I expect you guys to be doing, okay? So email me with any questions. It's been kind of nice to connect with a few of you as far as doing like video chat and doing problems on the whiteboard. I can certainly help with some of that stuff. Hopefully these aren't too bad because there's no graphs other than those last 2. So there's lesson 5.2. Kind of in the books. We'll come back and have a second day where we hopefully clean up a few things if we need to. Okay? So that's all I have for you today.